Last time we started to learn about trigonometric substitution. The important formulas was sine squared of theta plus cosine squared of theta equals 1, and 1 plus tangent squared of theta equals secant squared of theta. Those were Pythagorean identity. We also learned about the strategy. If you see the expression square root of a squared minus x squared, then you'd think about the identity 1 minus sine squared of theta equals cosine squared of theta. So by thinking about this type of identity, substitution will go as x equals a sine of theta. And square root of a squared plus x squared, then we would think about the identity 1 plus tangent square root of theta equals secant square root of theta. In this case, the substitution will be made as a tangent of theta. And another one was x squared minus a squared. Then you'd think about the identity secant squared theta minus 1 equals tangent square root of theta. So the substitution will go as x equals a secant of theta. I said all of those strategy and the trigonometry, the Pythagorean identity must be remembered. Today, we will work on the different strategy. So the strategy we will think about is a square root of a squared minus x squared substitution with x equals a sine theta. The problem is evaluate integration x squared over 25 minus x squared 3 over 2 dx. Here it is squared x squared. So pattern matches this pattern. So we will understand 25 minus x squared as 5 squared minus x squared. So in this case, we will do substitution with the sign. So in this case, a equals 5. So we will put x equals 5 sine of theta. Then when we differentiate, we have dx equals 5 cosine of theta d theta. This is 5. Let's simplify the denominator. Then 25 minus x squared to the 3 over 2 power can be written as 25 minus x squared will be 25 sine squared of theta 3 over 2 power So we take out 25, then 25, 1 minus sine squared of theta to the 3 over 2 power. So we know that sine squared of theta plus cosine squared of theta equals 1 from Pythagorean identity. So 1 minus sine squared of theta is cosine squared of theta. You cannot distribute the power to the first and second term when terms are added, but when terms are multiplied, you distribute the power to the first and second factor. So 25 to the 3 over 2 power times 1 minus cosine sine squared of theta is cosine squared of theta to the 3 over 2 power. So 25 3 over 2 power is 5 squared 3 over 2 power. So we just multiply these two, then we get 5 cubed, and then we multiply these two powers, then we get cosine cubed of theta, right? We simplify the denominator. We will go back to the original integration and do trigonometric substitution. X squared over 25 minus x squared to the 3 over 2 power dx. That equals integration. X squared is 5 squared sine squared of theta over this part we already calculated. That's 5 cubed times cosine cubed of theta times dx is 5 cosine of theta d theta. So if you multiply these two, then we get 5 cubed, right? So this 5 cubed and this 5 cubed will cancel each other. And then integration, when these two are combined, this is in the denominator. So denominator becomes cosine squared of theta. Numerator is sine squared of theta, and then d theta. So that becomes integration tangent square root of theta d theta. So we use the Pythagorean formula. So that is secant square root of theta minus 1 d theta. So again, the Pythagorean formula we are using is 1 plus tangent square root of theta equals secant square root of theta. So if we subtract 1 on both sides, then tangent squared becomes secant squared minus 1. So we do term by term integration. If we differentiate tangent, then we get secant squared. So if we integrate secant squared, we will get tangent. So tangent theta minus the second term is integration of 1 is theta plus c. We are almost done, but the original variable was not theta due to x. So we will change the variable again. What we did was x equals 5 sine of theta when we did the substitution. So sine of theta equals x over 5 we divided by 5 on both sides. And then that came from opposite over hypotenuse. So we visualize with the right triangle. This is theta. So opposite is x and hypotenuse is 5. And this side length is 25 minus x squared by using the Pythagorean formula. Any confusion or do you have any question? Okay, so now we can do substitution. Here, tangent is opposite over adjacent. So opposite is x over adjacent is square root of 25 minus x squared. And we know sine of theta equals x over 5. So theta is sine inverse of x over 5. So minus sine inverse of x over 5 plus c. Any questions? The next question may look very similar to what I'm doing. However, the simpler way to go is not using trigonometric substitution. Instead, you will use just a regular substitution method. Integration x cubed square root of 1 minus x squared dx. So what happens here is I said we will just think about the regular substitution method. Indeed, what I will do will be I will put this one as u. Then when we just look at the multiplication itself, what you can see is when you differentiate this part, we have 2x, not x cubed. But this x cubed can be split into x squared times x. And then you will start to see that we can do something with that. So let's put u equals 1 minus x squared. Then what I get is the u equals the minus 2x dx. So this part becomes u, but we realize that x squared can be written by using u. So x squared equals 1 minus u. So let's just do one by one. So minus 1, and then u minus 1 equals minus x squared. So if we multiply by -1, then x squared will be 1 minus u, just I switch the sign of each term. And from here, what we have is x times 2x. We are thinking about this part. So x times dx is minus 1 over 2 du. So we are ready to do all the substitution because we have the 3 components. So this component, and this component. So integration x cubed times 1 square root of 1 minus x squared dx can be written as x cubed dx can be written as x squared times x dx. So 1 minus u times square root of 1 minus x squared was u du. But there was -1/2, and that can be written as -1/2 in front of integration. Let's do distribution. -1/2 integration square root of u minus u square root of u du. We have to do integration, so we want to write that as exponential form. So that is 1/2 integration u to the 1/2 minus, what is this? This can be written as u times u to the 1/2. So u to the 1 power times u to the 1/2. So u to the 3/2 power. So let's do integration. Then that is 1/2 u to the 1/2 plus 1 over 1/2 plus 1. We are just following the formula u to the 3/2 plus 1 over 3/2 plus 1 plus c. And that is 1/2 times u to the 3/2 over 3/2 minus u to the 5/2 over 5/2 plus c. I think I missed one question. I didn't see the chat box from the previous problem. I will explain after I finish this. This one equals -1/2, and but I will just write. So this denominator can be multiplied as a reciprocal. So that becomes 2/3 u to the 3/2 minus 2/5 u to the 5/2 plus c. So if we distribute, then that becomes 1/2 times 2/3 and u to the 3/2 minus will make plus, and when we multiply these two and this two will cancel each other. But anyway, so we'll get 1/5 u to the 5/2 plus c. So those two will cancel each other. So we have -1/3. And u was, go back to here, u was 1 minus x squared to the 3/2 power plus 1/5. 1 minus x squared 5/2 plus c. Any question? So in the previous question, sine was defined as x/5. So when the input is theta, output is x/5. Theta can be represent it as inverse sine function's image because in the inverse sine function, the input and outputs are switched. So by putting sine inverse, we can make a theta as an output. So we just put sine inverse of x over 5. Am I answering your question, or I'm not sure why you are asking me why it is sine inverse? The purpose of doing that is the original variable was x, so we cannot use theta in the expression. So instead of theta, we understand theta as the output image of inverse sine. The next question is definitely a very hard type of question. So it's good to follow through and understand how to solve the problem. And you will have to do homework, which is similar to this pattern of the problem. However, for the exam purpose, this type of too overly complicated problem will not appear in the exam. So this is the last substitution, typical trigonometric substitution. When the expression is square root of a squared plus x squared, the substitution will use x equals a tangent of theta. The problem which is given for this pattern of application is evaluate integration square root of 36 plus x squared over x dx. So that fall into this pattern. So 36 plus x squared equals 6 squared plus x squared. So we will put x equals a is 6, right? So 6, those are added. So we have tangent theta. Then dx equals 6 times secant squared of theta d theta. With this information, we will do substitution. Let's go back to the question. Integration square root of 36 plus x squared over x dx equals integration square root of 36 plus, what is that? X was 6 tangent theta, so 36 tangent squared of theta. So x is 6 tangent of theta. So dx is 6 secant squared of theta d theta. Integration square root of 6 squared, open parenthesis, 1 plus tangent squared of theta over tangent of theta times secant squared of theta d theta. So what I did was I canceled the 2 out and I took out 36 here. And then wrote it as 6 squared. then that can be written as we just, let's separate this. Then that is square root of 6 squared times square root of 1 plus tangent squared is secant square root of theta over tangent of theta secant square root of theta d theta. So square root of 6 squared is 6. Integration, this one is secant of theta over tangent of theta times, what we will do will be, we will just replace secant squared as 1 plus tangent squared. However, if you just try to solve the problem without any clue, this problem is very, very difficult. It is really hard to see the strategy from here. But anyway, so it's 6 times. Let's separate. Then we multiply these 2. Then secant of theta over tangent of theta plus secant of theta over tangent of theta times tangent squared of theta d theta. Then we come up with the simplification. So what's happening here is a secant of theta over tangent of theta can be written as secant of theta times 1 over tangent of theta. So secant of theta is a reciprocal property, that is 1 over cosine of theta, and 1 over tangent is cotangent. So that is cosine of theta over sine of theta. So these two cancel each other, and we have 1 over sine of theta, which is cosecant of theta. Let me read the question in the chat box. Can you explain what happened to the square root of 6 squared after you split the integral? That went right here. Am I answering your question?
Yes, you are. Thank you.
Mm-hmm. So the first one is a cosecant of theta plus this one and this one will cancel each other, but this one was degree 2. And so this one will be reduced as secant of theta times tangent of theta d theta. So to proceed to the next step, what you have to know is the formula for the integration of cosecant of theta d theta. That is natural log of cosecant of theta minus cotangent of theta d theta. Another formula is for this part, which is relatively easier. That is integration of secant of theta tangent of theta equals secant of theta. So to conclude the integration with respect to theta, we just combine these two formulas. then that will be 6 open parentheses natural log of absolute value of cosecant of theta minus cotangent of theta and plus secant of theta plus c. But as I said, the conclusion must be x-related things because that is the original form of the integration. So we go back to this substitution. Then from x equals 6 tangent of theta, we have tangent of theta equals x over 6. So x is opposite and 6 is adjacent. So that means cotangent. What we have here is a cotangent. We have to find secant and cosecant, right? So when we visualize this in the right triangle, it becomes opposite is x. And adjacent is 6 when theta is right here. And hypotenuse is x squared plus 6 squared. I just applied the Pythagorean formula. So what is cotangent? Cotangent of theta is adjacent over opposite. So adjacent is 6 and opposite is x. And cosecant of theta equals 1 over sine of theta. So that means hypotenuse over opposite. And that is hypotenuse square root of x squared plus 6 squared over opposite is x. And secant of theta is 1 over cosine of theta. That is hypotenuse over adjacent, and adjacent is hypotenuse is square root of x squared plus 6 squared, and adjacent is 6. So we will combine all these together, then 6 times natural log of absolute value of, instead of cosecant, we will write this. So that becomes x square root of x squared plus 36 over x minus, instead of cotangent, we will write this one. So 6 over x plus square root of x squared of 36 over 6, because the last term was secant. The secant can be represented as x squared plus 36 over 6 plus c. Any question about this problem? We will do one more problem. The next problem is evaluate integration x cubed over square root of x squared plus 36 dx. If you look at the problem, again, this is a little bit elusive problem. So the first thing you may notice is, oh, this is x squared plus 6 squared. So maybe we will do substitution with tangent is 6. The x equals 6 tangent of theta. But if you go through that process, then the things will be a lot harder. In this case, it is better to use the substitution we did in the last example. Just u, we will put u equals x squared plus 36. Then du equals 2x dx. And so x times dx equals 1 over 2 du. What you realize is when you differentiate this, we have x dx, not x cubed dx. However, as we did in the previous example, x cubed can be written as x squared times x, and the x squared can be written as u minus 36. I just subtracted 36 on both sides. So we will combine all of those. So integration x cubed over square root of x squared plus 36 dx. That equals integration, this is x squared over in square root of x squared plus 36 times x dx, right? So x squared is u minus 36 over square root of x squared plus 36. That is u, right? And the x dx is 1 over 2 du. That is 1 over 2 integration u over square root of u minus 36 over square root of u du. We will use the power formula. So let's convert each term with the power. U over square root of u can be written as u to the 1 power over u to the 1/2 power. So that is u to the 1 minus 1 over 2 power. So that is 1 over 2 power, u to the 1 over 2 power. So the first term is 1/2 times square root of u to the 1/2 power minus 36 times u to the, this time square root of u is in the denominator and square root is 1/2 power. So that becomes minus 1 over 2 power. Du. And then all we have to do is a term by term integration. So 1 over 2, open parenthesis, u to the 1 over 2 plus 1 over 1 over 2 plus 1 minus 36 times u to the minus 1 over 2 plus 1 over minus 1 over 2 plus 1 plus c. This will make 1/2 and this will make 3 over 2. So that will become 1 over 2 times so what's in the denominator will be flipped and multiplied in front of the numerator. So that'll be 2 over 3 u to the 3 over 2 minus 36 times 2 over 1 times u to the 1 over 2 plus c. So let's just do distribution. Then that is 1 over 2 times 2 over 3 u to the 3 over 2 minus 1 over 2 times 36 times 2 times u to the 1/2 plus c. So those will cancel each other, and 1 over 3. And u was what? U was x squared plus 36 to the 3 over 2 power minus 1 over 2. And 2 will cancel each other, so we have only 36. And x squared plus 36 to the 1 over 2 power plus c. So any question? You have to just observe something. How you determine this? Firstly, the first sign you can think about is, in this case, the square root thing and a highest degree 1 appears in the numerator, right? Even if you differentiate this, then it'll be something like 2x dx. And that is associated with the numerator. In this case, the x is written in the denominator. And so if you think about the normal substitution, then there is no way to do well with the normal substitution. You are stuck. And then you realize that square root of something squared plus x squared is something to do with a tangent substitution. That's the way you will do reasoning. But in this case, the green sign is a square root of this one appears in the denominator. So the way you will think about this is, oh, let's just put this one as u. Then when you differentiate du, then that is 2x. So in this expression, x is somehow included, but unfortunately, x squared is multiplied to x. And so this is redundant, but as long as you will be able to express this one by u, then you can just change this part with a u related expression. And obviously we can do it. So we conclude that, well, we don't have to use the tangent substitution. And then you will just write down what that could be. And then you realize that you can just split this and simplify further and use the power formula. So basically, if a square root of something appears in the denominator, then it's worth to think about the regular substitution. But in the previous example, I also presented different things which it doesn't have to be in the denominator, but you still can think about this is x squared and this is x cubed. And so just when you split that into two pieces, this can be expressed by u, right? So if you practice more, then you will gain better insight. However, I didn't say that you cannot use a trigonometric substitution for this. Even if you just use trigonometric substitution with tangent, you will get the same answer, but it is a little bit harder to get to the point. What I'm saying is it's the matter of how many minutes you're spending to conclude the problem, rather than you cannot solve with the trigonometric substitution. Do you have any other question? Today is Thursday, right? And so we will meet in our regular classroom on Monday for another the open book quiz. So as I said, make sure that you master shell method and Washer's method, and think about the differences between those two methods, because I will give you a different function, then but definitely you will have to work out the problem with both shell method and disk method in the exam. Any question? What classroom? That is Math Science Building 406 on Monday. Any other question? Okay, if you don't have any other question, then you can leave. If you have any question, then you can continue to ask me question.